Okay, in this tutorial, I'm going to talk you through how you would go about creating a Choropleth map as well as a dot map. I'll discuss um, the strengths and weaknesses of both techniques and also get you thinking a little bit about how the two techniques compare against each other. In previous years in Advanced Higher, these two techniques have been questioned side by side because they're often seen as directly opposite as a data presentation tool. So let's start with the Choropleth map. Now, first of all, this map is often known as a shading density map, and you can see a really good example of one here, which is showing you the density of people in each of the 50 US states. Okay. My other example, which you can see here, is not a shading density map or Choropleth map. Okay. It is using color to show values against a key, which we can see here. But the thing is, it's using different colors to represent different values. So it would not be classed as a shading density or Choropleth map. Right, so let's first of all think about how would you go about creating a shading density map. The first thing is to think about your data set, your value range. Okay, so here we can see the value range from 0 people per square kilometer all the way up to very high values above 1,000. Okay, the second thing to think about is the color scheme that you want to use. So in this case, we're using red from very dark red, which the darker the shade always tends to represent the higher the value, down to a very light shade representing a low value. We can see here in this example of GDP in Africa, a very similar color scheme. However, this time it's done with green, dark green representing countries with high GDPs in Africa, and a low light green representing low values. Now, final thing is the number of categories. I generally think a good Choropleth map limits the number of categories to maybe 5 or 6 at most, whereas this has probably got slightly too many categories. There's 8, and it can be very difficult to see the difference between kind of colors which are quite similar. And the more categories you go for, the more likely it is you're going to have color shadings which are very very similar and very difficult to differentiate between. So for example, here we can see this state and this state, they look almost the same, but you can actually see that this state here is ever so slightly lighter. Right, one final key thing to think about when developing one of these maps is to actually be careful with your key. So you'll notice here we've got a value of 0 to 10 representing our lowest category, but then our second lowest category has 10 to 20. We have duplication. So if we did have a US state that had a population density of 10, which one would we use? So this is a poor key because it's actually done that, and that's been a mistake by the map maker. Here we can see a very good key because they're below 800, so that means 799 and below, 800 to 1199, 120 to 1499. You'll notice actually there is nothing from 1500 to 1699, and you might that the map maker could have chosen to add an additional category here, color, but probably because there were no countries in Africa that met that range, they've just skipped that, and that's allowed. It's up to the map maker. You'll also see that the intervals between each categories do not need to be the same. So here we can see the range for this color is 399. It's the same here, but here the range is much bigger from 1,700 to 399. And once again, that is allowed when you're mapping. The map maker for this map has done, sorry, I keep doing that, has done a very similar thing. The ranges between each of the categories are not the same. Okay, so that's how you make it. Now, once you have matched your categories and the spread of categories with colors, you've then just got to map it out on a map. Now, Choropleth maps are specifically showing maps that show you the average of something for an entire area. So here we can see California, and we can see it's a dark red color. We can match up to this color here and determine that the population density in California ranges between 500 and 1,000. Okay, so it's an average for the whole of the US state. It allows us to do some good data analysis, we can compare the 50 states against each other. And we can start to identify patterns. So I can see, for example, states over in the northeast of the US with the very high values. In contrast, I can see the Midwestern states have generally much lower values. It allows us to very quickly see anomalies. So an anomaly would be a state that is very different from the other states. So for example, down here, Louisiana, we can see is higher than the surrounding states, and that makes it jump out. We can also do very clear comparisons. So we can see California over here is much higher than its neighboring state of Nevada there. Okay, so it allows us to just compare very easily two states. So those are all of the strengths of using shading density. It's easy to read, and you'll have seen these maps many times in geography, using a range of contexts to present data, whether it's population density across the US or very commonly used to present national data to allow us to easily compare countries and see the patterns. So North Africa, for example, has very high GDP. The sub-Saharan region here in Central Africa has very low GDPs. Weaknesses, however. The first weakness is the data has to be an average for an area. Okay, so you have to have your data has to be gathered at the area level. So in this case, a US state, in this case, a country state. And it has to be averaged out. What this means, however, is we can't see variations in the state. So when we look at California, we just assume everywhere in California has between 500 and 1,000, whereas in reality, it might be that up here in the northeastern part of the state, there's very low population density, and we should really have that color. Whereas down here, where the cities of San Francisco and Los Angeles are, it's going to be very high. It's probably actually going to be way over 1,000. But we lose that internal variation because the data has been averaged. Another weakness is that we have these sharp cutoff lines between states. So we just assume that we've gone straight from an area of over between 500 and 1,000, right down to an area between 50 and 100. So if I was driving over the border, I would suddenly see a lot less people. Whereas in reality, that's not what's happening. That becomes even sharper when we look at country data, that we seem to have these real big cutoffs, and we think that this entire country up here, let me just show you, of Libya, has this high GDP all the way through the whole country, whereas in reality, almost all the wealth of Libya is in this small little coastal area around the capital, Tripoli. And if I was to go down here, I would see absolutely no wealth, because this is the Sahara Desert inhabited by tribes people that don't even deal in money. So the reality is we have an average and it's hiding. Likewise, if I go over the border into this country, it would be the same levels of wealth here as it would be just here. It's the same people, basically. And to find the wealth in this country, I'd have to go down to the capital in this zone. Okay, so borders create artificial boundaries, which we think then there's big changes or variations as we cross those boundaries, and often that's not the case. Right, so that's the strengths and the weaknesses of Choropleth maps. Let's compare it with its other technique, which addresses some of the weaknesses of the Choropleth map, but also presents new sets of problems. It's the dot map. Now, the strength of the dot map is the data is located on the precise location from which it comes. Okay, so in this case, a dot in the US represents 100,000 people. So if I go right there into this state here, I would expect to find roughly 100,000 people. Okay, so it's very sensitive to regional variations. So rather than being an average for a whole area, which is what we saw on the Choropleth map, it tells me where the data is actually in that area. What that then allows me to do is it allows me to very clearly see areas where there is relatively low amounts of people, as well as concentrations, because there are far more dots. And if you have 200,000 people in an area, you just have two dots. That actually creates one of the first main weaknesses, however, because if, for example, this is a city with 500,000 people, that would be 5 dots. But I can't put the dots on top of each other because I wouldn't be able to see the values. So what the map maker would have to do is then place the dots around this dot. Now, if it's a big city with 10 million, you can see you end up with this problem. When you have very high concentrations of values, they get overcrowded in an area and you can't actually differentiate between where the dots are and not. So I can't see any one dot from another dot. Another big problem with this is the actual value you choose. So I've chosen 100,000. If I happen to have a city of 99,999, I'm one person off 100,000. I cannot place a dot. However, if I have that one extra person, I can suddenly put a dot down. So the map maker has to choose what their cutoff point is. Now, clearly, if I set this a lower value, I will end up with a lot more dots on my map, which could be a problem. You could end up with something looking a bit like this, especially for this part of China and India, where the dot level has been set too low. Now, if I set this dot at 1 million, there would suddenly be a lot less dots on my map, and I'd be able to see patterns a lot clearer. However, large places of 500,000, 800,000 would no longer appear. So it's a trade-off, the actual size that you set your dot limit at. If you set your dot limit too high, you end up missing a lot of data. If you set it too low, you end up with too many dots and maps that end up looking very messy with dots on top of each other. It does, however, allow you to see gradual change. So we can see, if I just clear the map here and show you my next point, what's really good about this technique is I can see over here a high concentration, and then as I travel across the northeast, it's getting less, and by the time I get to the Midwest, it's dropped, and as I get to these kind of northwestern states, it really has progressed to very low levels of people. There aren't any of these sharp cutoffs that we saw with the Choropleth map. So here we can see a state with high population density and one with low. Okay, now if we actually go to this map, we will see that the actual difference between them is not massive in terms of dots. Okay, so that's dot maps. They're quite easy to create, and they do precisely locate your data, unlike the Choropleth maps where the average, but you can end up having a real problem reading them. It's very common to get exam questions where you get both maps and you get asked to compare and contrast them as a data presentation technique. And you will certainly be asked to have done some of those practice questions in class.